Alright, so in this video we'll go over how to implement a stack in JavaScript, but first we have to talk about what exactly a stack is. A stack is just a data structure in which the last element to be added is the first one that'll be removed. This is also known as LIFO, which is last in, first out. So think about it like a stack of dishes. Even though the bottom dish was added first, the top dish is what will be removed first. This is the opposite of a queue. A queue is FIFO, meaning first in, first out. So think about a line at a grocery store. This person enters the line first, then this person, then this person. The first person that gets in line is the first person that will leave it. Just to use this diagram here, we have 1 added first, then 2, then 3. The element 1 will be removed first because it's the first one that was added. Alright, let's move on to the stacks methods. The first method we'll look at is the method push, which means add. So all you're going to do is you're going to look at the first available index and you'll add the element there. So let's say we have the element A. Which index is available? It's index 0. So you add A, but then you immediately have to increase the index by 1. Why? So that when you add the next element, we could do the same thing. So let's say we add the element B. What's the next index available? It's 1. So you add B and you increase the index by 1, which will be 2. Just note that that index is always the same as the number of elements in the stack. So if you look at the index as 2, and that coincides with the number of elements that are in there. Now we're at the stack's pop method. Pop just means remove from the top. So the way we do this is we look at the size variable, but of course right now there is nothing associated with the size variable. So what we have to do is we have to look at size minus 1. Size minus 1 is 2, and what's the element there? It's C. So we grab a reference to C, and now the entire point of this method is to delete the actual element in the stack. So we delete C from here. Now if we look at it, the size variable is 1 more than it needs to be. So we have to decrease that by 1. And then the final step in any pop method is to return the element that we removed, which is C. Now we move on to the peek method. All peek does is it shows us which element would be removed next, but it doesn't actually remove it. So if we take a look, we obviously want to remove the element C because it's at the top of the stack. But we can't remove it using the size variable because the size variable points to 3, which has no elements associated with it. So what we have to do is we just return the element that's associated with size minus 1, which would be C. The size method is really easy because all we have to do is look at the size variable that we have already. Right now the size variable is 3, so that would actually be the size of the stack. And finally, we're at the empty method. All empty does is return whether or not there are any elements in the stack. And what we could do is, since we already have the size method, which returns the size of it, we can just use that to see if the size equals 0. All right, we'll implement this by adding our data to an object called storage. So this.storage storage equals an empty object. And then we'll need the variable size to keep track of the indices of the elements that we're adding and removing. So this.size equals 0. So basically what this is going to look like is, let's say we're adding the element A as the first element. Index 0 would be A. Then you would increase size by 1 if you're going to add another element. So that would be index 1 equals B. Next, we get to the method push. So remember that to add anything to this object, we just need to access the size variable. So this.storage, this.size equals the value that we need to add. And then we immediately have to increment size by 1. All right, now we're at the pop method. Pop method is 4 steps. First, get a reference to the element at the top. Let top equal this.storage, this.size minus 1. Because remember we said earlier that size is always 1 more than the index of the top element. Then we can delete that. So delete this.storage, this.size. Then we decrease size by 1 because it's 1 more now than we need since we just deleted an element. So this.size minus minus. And finally, with the pop method, the last step is to return the element that was just removed. So return top. Now we're at the peek method. The peek method just shows you the next element that would be removed, but it doesn't actually remove it. So it just returns this.storage, this.size minus 1. Now let's actually skip down to size. Size is the easiest of them all because we have a variable that keeps track of the size. So we'll just use that. Return this.size. And now we're at the method that returns whether the stack is empty. And we can just use this method that we created to tell us whether the size is 0. So return this.getSize equals 0. Now what I've done here, just to test it out, is I've added a few lines. So I'm going to create a new stack called stack. We'll add A and then B and then C. And then we'll take a peek at what's at the top of the stack. So let's do that now. That's correct. C is at the top of the stack since it's the last thing that we added. Then we will remove the top 2 elements. So what should be removed are C and B. And then we'll log what we see after the end, which should be the element A. And then we'll see what the size is. And since, again, we removed 2 elements, the size should be 1. Okay, so like we just said, the top after we removed the top 2 elements is A, and the size is 1. Remember that if you have any questions, the code and a written description are linked in the description below.